Hello everyone. So today we'll be looking at this Leetcode problem 594, longest harmonious subsequence. So let's look at the question. So it says we define a harmonious array as an array where the difference between its maximum value and its minimum value is exactly 1. Which means given an array, we first have to find the minimum value and then we have to find the maximum value in that. So we have to take the difference, like in this case maximum is 7, minimum is 1, the difference is 6. So it is not an harmonious array. But if we take this array, okay, this array, the maximum is 3, the minimum is 2, right? So the difference is 1. So this will be harmonious array. Given an integer array nums, return the length of its longest harmonious subsequence among all its possible subsequences. Okay, so whatever subsequences are possible for this, okay, so we have to list down those, and among those we have to find that which of those subsequences have the which of the subsequences have the harmonious subsequence, okay, and which is the largest, which has the largest length. Okay, we have to find that. So in this case, as you could see, that this is our answer. Okay, why? Because 3 minus 2 is 1, which satisfies the first criteria, which is the difference should be 1. And the second criteria is it should be the longest. So 1, 2, 3, 4, 5. There are 5 elements in this, and there is no other subsequence which makes the 5 elements. So if we take 1, 2, 2, 2, okay, it makes 4 elements, but this has 5 elements. That's why this is the answer. So output will be 5. So if you look at it, it might look like medium problem, but it's very easy. If you will see, you just need to create a hash map. Okay, so we will just see what's the frequency of each element. So 2 is occurring for how many times? 3 times. 3 is occurring for how many times? 2 times. So similarly, if you will see over here, we have created a frequency. Okay, that frequency of 1 is 1. 1 is occurring for 1 time. 2 is occurring for 3 times. 3 is occurring for 2 times in the above array. Okay, so once we have created this frequency hash map, after that what we have to check for each element, like let us suppose for 1, okay, we will check is there any element is there 0 or 2, okay, that is num plus 1 or num minus 1 present in this array. Okay, first we will check for 0, whether 0 is present or not. If the 0 is present, we will see the count and we will plus both the counts, okay, because that's what we are doing. We are checking the count of 2, we are checking the count of 3, and then we are summing that count, that is the length of the whole array. Okay, and it will always be the case that the answer, okay, answer will have only 2 elements, okay, and the difference between those 2 elements will always be 1. If there are 3 elements, then it is not possible, like 3 unique elements, it is not possible that the difference between them is 1. Okay, it will be greater than 1. So that is one key observation here. So that's why we just need to check the neighbors of every element. For 1, we have to check the count of 0 and 2. For 2, we have to check the count of 1 and 3. For 3, we have to check the count of 2 and 4. Okay, 3 plus 1 is 4. Okay, so similarly for 5, we have to check the count of 6 and 4. 6 and 4. But 6 and 4 doesn't exist, so for 5, it's not possible. Okay, because the difference minimum and maximum in 5 case will be itself, which is 0. Okay, so 7, for 7 also it is not possible. Why? Because 7 minus 1 is 6, 7 plus 1 is 8. So if you can see, 5 has not, 7 has no. For 3, it will be same. Okay, so 3 plus 1 is 4, 3 minus 1 is 2. Okay, so it will be 5. For 2, it came as 5, right? So for 3 also it will be 5. So that's how we will do it for every key. For 1 we have done, for 2 we have done, for 3 we have found, for 5 we have found, for 7 we have found. So whatever is maximum out of these will be our answer. Okay, because we have to find the longest subsequence. So maximum is 5, okay, and 2 is making with 3, 2 and 3. Okay, 2 is 3, 2 is occurring for 3 times, 3 is occurring for 2 times. So 3 plus 2 is 5, oh, that is the answer. So if you will see the time complexity, since there is only one for loop, okay, so the time complexity is order of n. Okay, basically 2 for loops are there, but if we simplify it, there will be just one for loop. So it will be like 2 of order of n, which eventually is an order of n. And for the space, since we are taking frequency hash map, so that is order of n. Okay, so let's check the code base. So in the code, if you will see, so unordered map we are taking, okay, and it is of int comma int, where int is the number and it's the frequency, like how much time it is appearing in the array. So we are just incrementing that and then checking whether there is a neighbor, like what's the frequency of neighbor to the left, what's the frequency of neighbor to the right, and for that those neighbor we are taking the count, adding it with this current number, okay, and updating our max length to max, okay. So whatever will be the maximum, we will return it at the end, okay. And this approach of work in a single loop works because even though for the intermediate numbers whatever are coming, it might, the answer might seem incorrect, but for the last number, okay, like if I have to explain you, for 3 2 2, the numbers might be incorrect, but when we have reached over here at 3, the frequency of everyone will be correct in the map, okay. We know that after reaching 3, the frequency in the map for 3 will be 2 and for 2 will be 3, okay. So that's why it will always be overridden in the max length, because we are taking always the maximum. So that's why in the single for loop we are able to do it. Got it? So let's see the second approach, where we will not take any extra space, but our time complexity will increase. So in that case, what we have to do is we have to simply sort this array. After sorting, what it will become? 1 comma 2 comma 2 comma 3 comma 3 comma 5 comma 7, okay. Then we will use the sliding window approach, where what we do is we take left equal to 0, we point right equal to 0, okay. So we will keep on expanding the right, okay, till the nums of right minus nums of left is greater than 1. And in between, if the nums of right minus nums of left equal to 1, okay, like in this case 2 minus 1 1, 1 minus 2 1, 1 minus 2 1, okay. So in this case these are 1, so we will keep on updating the maximum length, okay. As soon as it is greater than 1, like 1 minus 3, it is greater than 1, okay. So in that case, what we will do is we will increment the left so that the difference decreases, okay. So again we will keep on doing this. So as you can see, we are keeping on updating the left and right and updating the max length, okay. In the final, whatever is the max length will be our answer, which is 4. So in this case, since we are doing a sorting, so it is n log n, and after that sliding window takes order of n, so the net complexity will be n log n, and the space, since we are not using any space, so it is order of 1. So if we look into the code base, so first we are sorting it, as you can see, then we are taking a left pointer, and then using the sliding window approach, we are taking a right pointer, and what we are checking is if the difference is more than 1, nums of right minus nums of left is greater than 1, we will simply increment the left, okay. We did it right, we incremented the left. But if the difference is exactly equal to 1, then we will simply update our max length variable over here, okay. And right is already getting incremented in the for loop, so for that we don't need to take care in this. So that's the whole flow. Now if we compare both the approaches, so in the first approach we were using HashMap, in the second approach we were using sorting. Time complexity in the first approach order of n, in this case it was more, n log n, but in this case space complexity was less, which is order of 1, and here it is order of n. And here the data mutation, it didn't happen in since in the sorting we changed the order of elements, it happened, okay. So in the hash map, memory, like we are taking that extra memory, right? So that's why it will, like, this approach is only better if we can take any amount of memory, and this approach is better if we want a memory optimized solution, okay. I hope you like the video. Thank you so much.